Hi guys, in this video we're gonna see triple integration. So let's see how to do triple integration. So this is how your questions will be. So this is the form the questions will be. So first we have to do the inner integration. First we have to do this part alone, and then this part, and then this part. So this is the procedure, simple procedure. First you have to do the inner part, and then after the second part, after the third part, which is outer. So let's quickly look at the examples. So this is the question as I showed before. This is the form they are given. So we have to first before solving it, we have to first check whether the limits and with respect to variables are same, so whether they are correct. So in this case everything is constant, so no need. But sometimes these limits can be variable, so at that time looking at this order is very important, guys. So here it's constant, so let straight away go into calculation. So first we have to integrate this part alone with respect to x. So if we do that, what we get, actually what they did is uh, with respect to x, y and z are treated as a constant, so they just took it out. So just took it out, and they first doing this part alone with x alone, with keeping x alone. So if we do that, we used to get this, and then after that x cube, then after that you have to do the inner integration, and then after that third integration. So they just splitted it up because it's the way the limits are constant, so just split it up. But you can do in this way: first you have to do this, and after that you used to get something, and then you have to do this. So first if you do the inner integral, you used to get this, I think so, yeah. And after that you have to integrate it with y, and after that you have to put a limit so that you get this whole thing. Then after that you have to integrate with respect to z so that you get that whole thing. So in the next example we get to know how this is actually happening. So in this case they just splitted it up and done, so it may be a bit confusing. So let's look at the example which is here. So first we have to do the inner integration which is present with respect to x. So first the done integration, simple integration, and treating y and z as a constant. So x cubed by 3, so if you integrate x alone, x cubed by 3, and treating other as a constant, so you get the constant into x, and putting a limit c to 0, you used to get this. And these are all simple integration. After that you have to integrate this with respect to y, you used to get this, and after that you have to integrate the whole thing with respect to z. So at last you get answer as this. So and this is another question. So in this case these are variables, so we have to check whether this variable should not present in the limit anywhere. So that's the main condition to satisfy. So if there is a dz in either of the limits, either upper limit or a lower limit, z should not be there. So that's the rule. So if you see with respect to z, we are integrating, there is 0 and x plus y, but there is no z. So if it is interchanged, see in question it's interchanged, dx they gave, but x is present in the limit, so we have to interchange it as dz. So this is very important. Many students will make mistake here in this case. So after that a simple we have to integrate the inner integral. So they just took this y and z, I mean x and y as a constant, treated as x and y as constant. They took it out, and this alone is a variable now, so just they integrated it and put it up to limit. So after that you used to get this, and after that as usual simple, you have to integrate the second integral, and then you used to get this, and then third integration, then at last answer, simple. So now a fourth question, so evaluate this. So if you see here nothing is there, if nothing is there, you have to take it as 1 into dy dx dz. In this case it is a variable, so you have to check whether this y is present here or not. So it's not present, so the limit is correct. And dz, so dx, so x is whether present in second one, nope, so this is also correct. And dz, whether z is there, nope, so this is also correct. So this is a correct order. So first we have to integrate the inner integral. So one, so integrating one will give the variable as it is. So y to the power upper limit lower limit, just substituting upper limit minus lower limit used to get this, and then inner integral which is integrating this. So this is a formula. There is a formula, root of a square minus x square. They used that formula, and then they they integrated and substituted the limits, and at last you have to get this answer. Simple. So this is all self-explanatory, guys. I know don't need to explain it. So these are simple. Just by seeing and looking it up, you can understand what it is. If not, then comment below. Then this is another question which is similar to that. So first we have to check whether z is present here or not. Nope. So this is correct order. Dz should come first, and dy. So here also there is no y present, so this is also correct order. So this is an correct order. So now we have to proceed to the integration. So first we have to integrate this part, and then after that this part, and after that this part. Simple. Simple integration, simple steps, simple simplification. So you can see just self-explanatory. These guys are. Uh, that's it. Using Bernoulli's formula, you just Google what is Bernoulli formula. Actually, it will come like first we have to integrate and then after differentiate it two times, something like that. It's a series. So just search and learn many things, guys. In YouTube also many videos are there. If I used to say everything, then you may probably forget it easily. So just search many things and learn it. So then only you used to remember it for a long time. So these are simple integrations. At last it finished. So this is another question. So here we used to take first we have to check whether this order is correct or not. So dz, z is not present, correct. Dy, y is not present in second element, so this is also correct. So dx, so x is not present. Okay, this is a valid order. So now we have to integrate it. First we have to integrate this part alone we have to integrate. So dz, so z is a variable, then all other things are treated as a constant, and we know that this formula, integral of dz, dx by, so this is in this form. We have to change it into this form. So if you take this as a constant, it's nothing but a square. So root of this to the whole square will give the same thing. So they took it as a square. So this is a, so that's how we got this. You understand? So and then we have to, and then it's a simple integration. So second integration with respect to y, then third last integration with respect to x used to get this. Simple. These are simple integration steps. And similarly, so just like in another just like above problem, you have to do this. Simple. So this is something different from all other problems which we've seen before. So evaluate this over the volume. Evaluate this integration, this triple integration over the volume enclosed by three coordinate planes. What does it mean? This is a very important point, very important line. If we miss it, we may probably end up in a wrong answer. So three coordinate planes. So three coordinate planes in the sense, these are x, y, z. So this is one plane, this is one plane, and this is one plane. So they are indirectly mentioning the first quadrant, so the first octant. So this is that. So in this first octant or quadrant, whatever you say, we have to find the volume enclosed by the planes, and also the plane of equation x by a plus y by b plus z by c is equal to 1. So how to plot this? How we know this equation look like this? Simple. Just substitute 0. So substitute the 0 in y and x. So you get x is equal to a. So x is equal to a. This is a. Just point it there, and as usual, if you do that, you used to get z is equal to c by putting x and y 0, and you used to get this as a b. So this is not a, guys. This is a printing mistake. Here 0 should come. So 0 b 0. So this is b. So if you join it, you used to get the plane. So now how do we find the volume? How do we evaluate it? So this is nothing but literally the volume. So first we have to take a point from a base to the surface of the plane. So this is the surface of the plane, and and the equation of the surface is given by this equation. This equation nothing but this equation, just they wrote as z is equal to, by transferring all of the variables to the right hand side. So z is equal to, so why they wrote in z is equal to, why can't they write in x is equal to or y is equal to? Because there is a reason. They are projecting this 3D object to a 2D object from a z plane. They are looking from here, they are looking from here. From you looking here, you used to get this as a shape. So you are projecting it to the xy plane. So what coordinate is not included? Z. So that should be written in this form. So z is equal to, if you are projecting in this way, then you have to write y is equal to something something, so something like that. So z is equal to, so first, for a triple integration, so first you have to integrate the surface. So what's the limit of the surface? It's nothing but the 0 to the z is equal to something, so this part. And then you have to omit the plane which is in 3D. So this plane we have to omit, and now take the things which is present under this, the projected things, which is this area. So now, like a double integration, you have to take a strips, and by following you have to plot the uh, I mean the limits which are present. So it's 0 to b into 1 minus x by a. How this came? So it's nothing but if this is a 2D xy plane alone, so you are omitting z by putting z is equal to 0. You used to get this. How you get this? By putting z is equal to 0 in this equation. Z is equal to 0. You used to get this. Okay, so now they took strip parallel to y-axis. So y is equal to something like that. In this form you have to write this, and that is nothing but your limit. So it's 0 to 0 to the equation of this line, that's nothing but this. And it's 0 to a, this is a. So strip is taken in this way. The first integral will be the y with I mean with respect to y, and then with respect to x. What is the limit of x? It's nothing but 0 to a na. So 0 to a, simple integration. After that you used to get the answer what you need. Simple, just you have to do is, just you have to find the limits for this, that's it. If you find that, then everything will be easy. So these are simple integration steps. If you can't understand any steps or particular steps, just comment below, I can help you personally. So these are all the exercise. Just do the exercise and comment the answer below. I will show the answer in the next video. Bye bye. If you really like this video, just subscribe it, simple matter, it's free.